Okay, so, whoops. Well, okay, well, those are the answers for today's quiz, but maybe you didn't catch it. That's okay. I will let you know. Oh, it's hidden right now. Okay, unhide, show. All right. So, I have sent out. I've invited you to take the HackerRank Stats 21 practice exam. So that's going to be your homework this week, okay? It's not, I think I assigned it like 90 minutes to take the exam. Just put yourself somewhere where you can kind of focus and you'll start writing your code. You get, I think this exam is 3 problems, 90 minutes, and that's it, okay? It's just going to be a homework. You either did it or you didn't do it, okay, as far as your homework grade goes. Now, of course, you should try to get the best grade and get familiar with the HackerRank platform. And if it works moderately well, then I think I will go forward with using HackerRank for the final exam. And we'll see how it goes. You know, if it's a total disaster, then I will have to think, and I'll have to think about what to do for the final. Is the final going to be timed like the practice test? Yes, it will be timed, and yeah, we'll figure something out from there. Okay, so will there be no multiple choice questions if we use HackerRank? That's correct. It will be a coding exam. Yeah, unless like if this HackerRank homework assignment thing, if it like goes terrible, then I'm gonna have to rethink, and maybe it goes okay enough, but yeah. So I guess I'm just trying to figure out exactly how to conduct a final exam for our class, and you know, I want it to be something where you can at least it will at least reflect some sense of learning of at least basic Python stuff, I guess, you know what I'll also do? I'll also add a place to give me feedback regarding HackerRank, and you know, maybe it's hard, right? Evaluating someone's programming ability is an inherently difficult task, and you know, HackerRank may not be the perfect solution, but it is something that many companies use as a screening tool. I would say their final hiring decisions are not based on the HackerRank exam, but a lot of companies will use HackerRank as a screening tool. So they might get thousands of applications, and then they just kind of say, all right, well, everybody take the this HackerRank screening thing, and then how you perform there will at least get you to the next step. Okay, so I would say it's used as a screening tool, and of course many companies don't use it, but many companies do. Okay. Question, should we expect everything on the practice exam to be covered in the lecture material? I believe I've covered enough in the lecture material for you to do well on the practice exam. It's only 3 problems, and I intentionally chose what I thought were easier problems, okay? And the only requirement is that you kind of solve them using Python. HackerRank, I think, allows you to use different languages, but obviously for this course, you'll be using Python. And I've chosen the option where it is not going to, so depending on, so different companies will have different policies, and HackerRank, one of the policies that HackerRank allows you to choose is when you open the browser, you have to stay on the HackerRank page, and if the computer detects that you opened another browser or you did something else, then it will like flag your test and stuff. I am not going to do that. Okay, so the way I plan on doing this is I'm leaving it open notes, open book, open internet. Okay, so if you're like, oh, I forgot what was the method I'm supposed to use, you're allowed to go to Google and say, Python, how do I do this, right? That's fine, okay? Obviously, do not, like, if the problem says, like, write a function that will, detect palindromes, don't search the internet for how do I write a function to detect palindromes on Python and look for a solution that already exists, okay? That's going to get you in trouble. HackerRank has its own plagiarism detector machine or algorithm. I don't know the details of how it works. This is the first time I'm using HackerRank, so I have no idea what this plagiarism report will look like. But HackerRank tells me that they do have a plagiarism detector. I've never given a test on this, right? So this is my first time, so I have no idea how it works. But HackerRank says they do have something like that. So I would just say, you're allowed to go on the internet and you're allowed to look up things, and but obviously I would say don't search for the solution straight up. You're allowed to look for things like, how can I subset a string to the last character? That's fine, right? And then you'll say, oh yeah, you just do square bracket -1 on the string, and that's fine. But as far as the actual solution, I would say don't search for those things. And I'm doing this now before the final exam, just in case something goes terribly wrong and we realize this is not going to work for a class. Okay, I'm hoping it goes well enough that people who experience issues, it's not too many. Like if only a small handful of you experience issues, I will probably feel comfortable moving forward in the with it for the final exam. But if it's like a ton of people can't get this to work, then I'll try to think of something else. But hopefully that won't be the case. And it is something that a lot of companies do use, so I think it's good to give you some practice using this kind of form. And again, it's not a perfect solution, but a lot of places implement it as a screening tool. It's tricky. It's hard, right? UC's just announced they're getting rid of all standardized tests in a few years, and there's pros and cons to every major decision like that. So using some kind of test like HackerRank for screening candidates certainly has its pros and cons, and we'll see. And if we have to make adjustments, I'm ready to do that. So anyway, that's your homework 5 for this week. It's I think I've given you 90 minutes, which really limits how. So certain coding problems, yeah, they also give you kind of like how much time should be expected, and so I kind of gave you according to HackerRank, they'll say like this problem is expected to take 15 minutes, and so I think as I've selected 3 problems that are about 15 minutes each, and HackerRank says suggested time 45 minutes, and I allocated 90 minutes. So we'll see how that goes. It'll time you, and it will give me a sense of how this is working, and if this is a a tool we want to continue, if I want to continue using or not. So, you know, please don't intentionally tank your HackerRank practice test. Okay, I know I said it's not going to count for points, and so you might be tempted to like intentionally fail it and get a 0 and say HackerRank is a terrible tool or something. Please don't do that because then I will have to think of something entirely different for the final, which I'm ready to do, but then it will be an entirely untested form. At least with this, I can start to, if everyone gives a good faith effort and I can see the results, then at least I can make an informed decision about how to go about doing the final. So, so please make a good faith effort, and if you find the problems on HackerRank to be way too hard or something, you know, I'll give a feedback form, and I'll try to figure this out. Okay. It's tricky. It's tricky. All right. Do you guys have any questions about this? Maybe we're okay. Well, I guess you'll take it, and then and you'll see. I don't know. Has anybody taken a coding thing for like a interview screen or anything like that? Has anyone had any experience like that? Not yet. Not yet. Maybe. Okay. So I did send invitations out earlier today, maybe like an hour ago or so. So hopefully you have received the invitation in your inbox. And if not, check your spam. And if still not, send me an email and I'll resend the invitation to you. Okay, let's see here. Okay, let's do our notes then. All right, so today we'll cover more pandas stuff, and this is we're going to look at the multi-index and hierarchical indexing. Actually, you can ignore this last line. Matplotlib, we'll ignore that. But we'll look at hierarchical indexing, which is how pandas allows you to kind of do like grouping summaries and stuff. Okay, so I am creating a multi-index. Okay, so I'm going to just take some 9 random numbers, okay, and I'm going to create a multi-index, AAA, BBB, CCC, and the second part of the multi-index goes 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this is a series. It's a series of random integers with a multi-index. Okay, and this is what it looks like. So here are my 9 random numbers, and here's the multi-index. There is 2 levels basically. Okay. There's A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, the A's in the first level are hidden, but this is A2. You don't see the A there because just kind of for formatting, Pandas chooses to kind of say, you know what, these things go with the A, so so it doesn't bother kind of printing this, kind of just a stylistic choice there. But this is A2, this is A3, this is B2, and this is B3. All right, and then if you ask what is the index on the series, okay, the index comes back as what's called a multi-index, okay, and you can indeed see each entry has an index, right? So there's only one series here, okay, and it's these integers 589500176. Each value, the index itself is a tuple, It's a tuple of A and 1, A and 2, A and 3, B1, B2, B3, so on and so forth, right? And Pandas calls this a multi-index, a list of tuples, basically. All right, and so when you say, based on the index, give me everything B, okay? Well, it pulls out basically this part, gives you 500, okay? And when you say B, it retains the inner index, this second level index, which is 1, 2, and 3, and it gives you the values associated with that 5 and 0. So it's basically pulling out this section, and it retains the inner index, the second level index. You can also select the second level index, okay? And for that, okay, so notice the format here where you're saying basically give me all of the, you know, for the location, okay? So again, this is a series, right? It's a series. So traditionally, with a series, you can just select via one thing. This is not like rows and columns, okay? This is a series, and basically it says give me everything from the first level index and give me everything that's equal to 2 in the second level index, okay? And so so we can see second level index is 8, or second level index, whereas 2 is going to be 8 for the A, 0 for the B, and 7 for the C. And that's what we see here, 8, 0, 7 for A, B, and C. Okay, and both of these, when you do that, when you ask, what are these? It's still a series, and this is just a regular old index, not a multi-index. Okay, if you take the series, okay, which has a multi-index, you can unstack it. Okay, you can unstack it. Right. So what that does, so here it is. Okay, it's ABC, and what we do when we call unstack is it's similar to calling pivot wider. Okay, and so what it does is it basically takes those A entries and it pivots them. So it turns them from kind of in this row 5, 8, 9 into from the column 5, 8, 9 into a row that goes 5, 8, 9. All right, so if we look here, you know, these values 5, 8, 9, which are associated 1, 2, 3, will get, you know, pivoted, okay? And here 5, 0, 0, which are currently stacked on top of each other, will get unstacked as such, okay? And this is a data frame, okay? This is no longer a series. The original thing was a series. This is now a data frame, okay? The index, if you ask what's the index of the data frame, the index is basically the row, okay, A, B, C. If you ask for the columns, it will be another index 1, 2, 3, okay? And the shape of this thing, as we can see, is a 3x3 data frame. If you unstack it and you create a data frame, you can ask to stack it back up, and you basically get back the original thing, right? So stack and unstack are kind of inverse operations. So you can take a series with a multi-index and unstack it into a data frame. You can also take a data frame with kind of these two indices or things, and you can stack them and turn it into a multi-index. Okay. So here is kind of the original data. Well, it's data unstacked and stacks, but it gives you back the original data. You can also do something called swap. You can swap the levels of the multi-index, right? So here right now, A is the outer index, the first level index, and 1, 2, 3 is on the inner index, the second level of the index, and we can swap them, okay? And so when we swap them, it does not reorder the data, okay? It just swaps them, and so now we get 1A, 2A, 3A, 1B, 2B, 3B, 1C, 2C, 3C, okay? So this, so because these do not align here, you know, it doesn't, stylistically, it doesn't hide the, like here it hid the letters A, but here, because the 2 and the 3 are different, it's going to keep them, okay? And it does not hide these because this is an inner, it's at an inner level, and so the inner level will always kind of be kept compared to the upper level there, right? And again, if you can say, you know, give me everything that has A for the second level of the index, and indeed it gives you exactly what you're expecting, 5, 8, 9, and so on and so forth. Okay. If you want to, you know, once you swap the level, you can then have it sort based on the index, all right? And then you get that, right? 1A, and now because it's sorted the kind of the top level of the index, all right? Those ones get hidden, right? So 1A, 1B, 1C will now be 5, 5, and 1. We can see, indeed, 1A, 1B, and 1C. You can sort after you swap the level, right? So this would be kind of, you can have an index of first names and last names, and then you can sort by that, or you can swap the levels and it'll be last names and first names, and you can sort based on that, right? So you can create an index that way. All right. The original data is left unchanged. The original data is left unchanged. All of these things basically returns copies that do not actually affect the original data. Okay. Here, look what I did. I swapped the level and then unstacked them. Okay. And compare that to just taking the original data and unstacking them. And so these are basically transposes of each other. But here is, you know, so there's multiple approaches to different things, right? If you wanted this, you could have unstacked and then transposed it. Here we swapped the level and then unstacked, but it behaves in a predictable manner, right? So when we swap the levels, then the 1, 2, 3 becomes the top level index, and the ABC becomes the second level index. And when we unstack that second level index, they form the column headings, so on and so forth. Okay, so that's that's the multi-level index that you can kind of stack and unstack, right? Here you can call sum on the entire data frame, right, or the entire series. Right. So right now, data is a series, and if you sum all 9 values in the series, you get 41. Okay? You can also sum based on levels of the multi-index, right? So you can say sum at level equals 0, right? Level is the first level of the index, okay? And basically, the sum of the A values is 22, 5, and 14, and we can easily verify, you know, adds up to 22, 5, and 14, right? And then if we say sum on the second level, so again, the original, you know, this is the original data, right? So we can say sum on the level 0, and then we'll get a summary for A, B, and C. Or we could say sum on the second level, and we'll get a summary for 1s, which will be 5, 5, 1. So we'll get 11. And then for the 2, we'll get 8 plus 0 plus 7, so we'll get 15. So we'll get 11, 15, and I forget 15. 11, 15, and 15. All right, so we can kind of do these summary functions based on the multi-index, right? The multi-index also allows us to reshape and pivot the data, right? So here I've created a data frame, okay? Data frame with 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, and the rows have the index alpha and beta, and the columns have the index 1, 2, 3, right? And so it calls the index on the column is called numbers, and for the rows we have the letter as the name of the index there. Okay, so we can do this. So here's a data frame, and what I can then do is I can take the data frame and just call stack. Okay, I can take the data frame and I can call stack. So, so you can create a multi-index just by calling stack onto a data frame, right? So you can imagine importing a CSV, and it automatically creates kind of your row names and your column names and stuff, right? So can you create a multi-index with more than 2 levels? Yes, yes, you can. It gets a little bit harder to work with, but yeah, you can create multi-index with more than 2 levels. So here we have this. I'm focusing on 2-level multi-indexes because it's probably very common when we're working with data frames, because it's a natural thing. You can just call stack on a data frame, and it will automatically generate a multi-index. Okay, so here now I get alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, and again you can call stack and then unstack, and it undoes that, and you get basically your original data frame. Okay. You can also, when you call unstack, so generally the unstack will unstack the innermost level of the index. Okay. But here you can say unstack level 0, right? So when I stack them, I do this, and generally it unstacks the lower level index, which will be the 1, 2, 3, 1, 2, 3. But here you can also unstack level the level 0 index, the 0 level of the multi-index, right? So then it's going to spread basically on the alpha and the beta, and so you can get this, right? And which, again, depending on what you're doing, they're pretty much transposers of each other. Okay. You can also, when you specify unstack, you can just give it the name of the index to unstack rather than the index, right? So this and this are equivalent. Here I'm calling it unstack on the letter index, and here I'm saying unstack on the 0 level index, and they are equivalent. Okay. Or you can say unstack on the number, which is just equivalent to regular old unstack, because number is the innermost index level. Depending on your data set, okay, unstacking can introduce missing values, right? So here I've got the inner index is A, B, C, D, and for 2 we got C, D, E. So when I unstack this, okay, if I unstack the innermost level, I'm going to get 1, 2, and then I got A, B, C, D, and then missing NaN, and then I got NaNs on the AB, right? So we can see that happen. And then notice, because when I unstacked it, introduced NaNs, NaNs are always floating point, and so it upcast the integers to floats. Okay, that's just what happens. All right, and so when you call stack based on this, right? So here I've unstacked it, and then I'm going to stack them back up. Okay, we get pretty much the same thing, but now everything is a float. Okay, so before we saw, when you call unstack and stack, you get the same original data. Okay, I'm not going to, like, this would be like a tricky question to put on a test, right? If I said, okay, here's data 2, and then if I unstack and stack it, what are you going to get back, right? Your initial gut answer is like, oh, you're going to get the same thing back, right? But you don't. Okay, here they're integers, but the unstacking upcasts everything to floats, and when you stack them back up, they remain floats, right? So that's like a aha, I gotcha type of test question that I don't want to go down that route. But you know, if the HackerRank thing totally becomes a disaster, and I have to write like a multiple choice test or something, or some kind of short answer test, you know, there might be like a couple tricky questions, right? As we call these questions discriminator questions, right? There's I don't even know what effect. how effective these things are, right? If you make everything easy, then and everybody gets 100%, which is what the students want. Unfortunately, it also gives you the test administrator no information about the difference between students. But anyway, but then if you throw in too many hard questions and everybody fails, it also doesn't give you information either. So you want a good mix of easy and hard questions. But anyway, okay. The other thing you can do is also you have the option to keep all the NAs. So you can say drop NA equals false. And remember, what we're doing is we're dealing with this thing, right? This is what we get after unstacking. It introduced nans and it upcast everything to floats. And we can say, well, what if we stack that back up? And you can keep the nans, okay? And so now you have kind of the complete index of A, B, C, D, E, and A, B, C, D, E. All right, so here's just like the teensiest, tiniest example on how this stuff could be used in a I don't know, data wrangling context. Okay, so this comes from the there's a I should have done that. The stats models. So stats models is a package that you can use for doing stuff, and we got some macroeconomic data from this 50-year span from 1959 to 2009, which is now outdated by 10 years already. It's hard to believe, but here we go. Okay, so when you look at this, okay, and you import the data, all of these things come in, right? You got year, quarter, real GDP, real, I don't know what all these things are, real consumption, expenditures, private domestic investment, federal consumption expenditures, and gross private disposable income. I'm not quite sure how all of these things are measured. Consumer price index, M1 nominal money stock. I have no idea what that is. M1 nominal money stock, do we know what that is? Okay, the treasury bill rate, all sorts of stuff, right? Okay, so I guess if you're into macroeconomics, that was not my major, so I have no idea what any of these things really mean. This is what we have, right? So we got 1959 and the first quarter. This is what we have. The GDP is this, and the consumer, I don't know, whatever. Okay. So with pandas, you can just call dot head to get kind of the first few rows. By default, it'll give you the first 5, but you can put in a number here, and it'll give you like the first n rows that you want. Okay, so we can see this, right? Okay, and so what we might want to do is we might want to turn this year and quarter information into like a date, right? So this should not be a float. This should be an integer or something, right? And the quarter should also be kind of an integer or a categorical variable or something, right? So what we can do is we can create an index, and Pandas has something called a period index, okay? Period index is basically to create time-based indices based on a period. So you can say like, I want based on the quarter, based on the week, based on the day, et cetera, the month. And so here, so you can read the help. You can read the help on this, and so you can give it all sorts of stuff: year, month, quarter, day, hour, minute, second, and it gives you stuff, right? Okay, so we're going to take the year information and the quarter information. Okay, we're going to just take the column data.year is the column year, data.quarter is the column for quarter, and we're going to call this, we're going to give our period index the name date, right? And then so pandas goes through, it goes, oh, 1959 and 1, oh, that's 1959 Q1, 1959 Q2, 1959 Q3, and it creates a period index based on the quarters. Great, okay. And okay, so what we're going to do is I'm going to just select 3 of these columns just for simplicity here, okay. And so so we're going to create an index based on this, and then what happens? We're going to call reindex. So do you remember reindex from the last lecture? It's going to conform the data to just fit the index that I've chosen, right? And so here basically it's going to just, in our case, just subset to those 3 columns. Okay, it's going to subset to just those 3 columns, and so we've got the GDP, inflation, and unemployment, and here I ask for the first 10 rows. All right, and regarding, so jumping ahead here, periods is this period index, okay? And it's currently a period index 1959 Q1, 1959 Q2, 1959 Q3, and so on and so forth. There's a function that says, you know what, turn those periods, which is 1959 Q1, turn it into a date, okay? And so we can call it, make it to a timestamp, and if you look up pandas index to timestamp, because that's what we're doing, right? All right, is that what I did? No, to date. Okay, so it'll cast the date time index had to be to basically your desired frequency and things like that. Okay, and that's what we're doing. We're going to do it on a kind of we want it at the date level. So this is going to be 1959 January 1. Start of quarter 2 is 1959 April 1. Quarter 3 is 1959 July. July 1. I drew a blank there for a second, right? Okay, and so this is, it broadly, loosely aligns with our UCLA quarters, right? So winter quarter, spring quarter, summer, and fall, sort of, not exactly. And so this is what we have, and it goes all the way up to Q3 of 2009. So we have 2009, 07, 01, right? You have other options. You have the start, which will be basically January 1, or you can also call the end, which will be basically March 31, and this will be like June 30th, and this one would end at September 30th, and this would end December 31, the fall quarter. Okay. Right now, the index is just the integers, okay? And so what we're going to do is we're just going to replace it, okay? We just replace the index straight up. We say date index. We're going to take these periods to timestamp and just replace it. And here we go. This is our data frame. This is the head of our data frame, right? And so what I can do now is I can take this and I can stack them. Again, now the series of all of this stuff here, okay? Stack them. And now I can do some stuff. Okay, so one thing you can do, all right, so I stacked this and I created this thing. You can also, with this series that I've created, I can call reset index, and it's going to kind of turn it back into a data frame, and it's going to reset it using just kind of giving a range index, starting the integers from 0 to 4 and so on and so forth, and date becomes a column, item becomes a column, and then the values, which had no name before, it just gets a 0 for the column name, right? So that's one thing you can do. And so the index here is just a range index, 0 through 609. Okay. I'm going to rename that last column, which used to be 0. I'm going to rename it to value. Okay. Kind of pick something a little bit better, right? So the rename, you basically give it a dictionary of which column you want to rename and things, right? Okay, if you try to call unstack, it's not going to work, right? Unstack doesn't work because there's no multi-index. There's no multi-index to unstack, so it doesn't quite work. Okay, but what you can do is you can call pivot. You can call pivot on this data set, right? And so so pivot, you basically say which column you want to be the index, and you can pivot you give it a name for the second thing that's going to be pivoted out, and then the values to fill it in. Okay, so this seems entirely worthless because it basically gives us back the original data that we had here, right? So this is kind of what we had here after we gave it an index. So you can stack it and all of this stuff, and pivot allows you to kind of just mess around with the data. So this is kind of silly, but it's just kind of showing that even if you didn't have all of the indices, if everything was kind of stored in this long form, okay, pivot allows you to kind of work with something even if you have not yet created a multi-index, right? So here we don't have a multi-index, and if we wanted to do the unstacking, how would we go about doing something like that, right? So if you have the multi-index, obviously you don't have to do any of this stuff, right? But here I'm just showing you, like, if you're in a situation where you've imported the data and it comes in like this, and you don't have a multi-index specified, you can't just do unstack, right? But there's other things you can do, right? There, pivot is one of these options, and you can read up on how pivot works, right? So it's going to create a pivot table based on the column names, and it will do this, right? So it gives you kind of some examples here of how this might go, right? And here we have the examples. So read through the documentation. It's always helpful. Okay. You can also, if you chose to go the other way, right? So here I did date to kind of form the row index, and I did item to kind of form the column headings. There's nothing keeping you from doing it the other way, right? So you can do the row index being the item and the column headings being the date, and now you basically get the transpose of the thing, and you have this big long 203 columns. It's cut out a lot from 1961 to 2007. These are all missing because you're like, that doesn't look like 203 columns. Yeah, it's not. So you have this, okay? And again, the original data was this, so probably it wasn't necessary for us to do it. But if you're ever in a situation where you don't have a multi-index and you want to do something like unstacking or stacking the data, you can use the pivot option, okay? Pandas has quite a bit of functionality, and we're only scratching the surface in kind of this intro-level course where we spend a few lectures on the topic. So group by is really handy for summarizing our data, and we'll see if I run out of time here. I probably will. Okay, so here I've got A1, A2, B1, B2, A1, and I've got different values, 5, just some stuff. Okay, currently this is no multi-index, right? It's just the index is 0, 1, 2, 3, 4. It's just a range index. Okay, but we've got these different column headings: key 1, key 2, data 1, and data 2, right? So what I can do is I can say, you know what, let's take this column in data 1, df data 1, okay, and then let's group it. Let's group it by key 1, okay? So we're going to get groups based on basically A's and B's, okay? All right, and so we can call, all right, give me the mean after I've grouped this data, right? So we're going to take a look at data 1. We got 5, 11, and 9 for A. And we said, what's the mean of those? We get 8.33. And then for B, we got 12 and 8. And what's the mean of those? 10.0. Okay. Again, just here's our data frame. You can just do a data frame and say group on key 1, and ask for the mean, and it's going to give you the mean of everything that has a numeric value that can be calculated for me. So it's going to group all the A's together and calculate the mean of this and calculate the mean of data 2, and so it gives you back another data frame where the index is AB and the column index is data 1, data 2, the columns that are from the data frame, right? You can also, so here's the original data frame again. You can create a group, you can give it basically a list of keys, right? So we can say use key 1 and key 2 for the grouping, okay? And this will create a multi-index for the groups, right? So we can say, so again here, we're just looking at data 1, okay? So for data 1, what's the average of where the entries where key 1 is A and key 2 is 1, right? So we look at A1 is 5, A1 is 9, and so the mean there is 7, okay? We say A2, and there's only one entry there, so we get 11. What about B1? There's only one entry there, so we get 12. And what about B2? There's only one entry there, so we get 8. Right? And again, because I have a multi-index, I can do things like unstack. So here, this seems weird, okay? Like, where did California in 2005, 2006 come from? Okay, here I'm just making up, okay? It has, these things have nothing to do with, this has no association with key 1 or key 2 or anything like that, okay? All I'm doing is I'm saying, oh, you know what? This thing has 5 rows. Here's a completely separate array that has 5 entries in it, okay? So I went Ohio, California, California, Ohio, Ohio. You can see that it lines up with nothing, right? It doesn't line up with the A's and the B's or the 1s and the 2s, right? I just created my own kind of index here. I've got 5 entries here, 05, 05, 06, 05, 06 or something, okay? And we can say, you know what? Grouped by these vectors, these arrays that just happen to have the same length of 5, okay? And what it's going to do is it's going to basically, you can imagine, like in your head, you're just adding the column states and years over here, and then you're using them to kind of group it, right? So it's going to say Ohio is the first and the last 2 rows, and we can say, okay, well, what's for data 1, the first and the last 2, 5, 8, and 9, what's the mean? 5, 8, and 9. Oh, I got to go with 2005. Okay, so 2005 Ohio is the first row and the 4th row. Okay, Ohio 2005. So first row is 5 and the 4th row is 8. Okay, so what's the mean of 5 and 8? 6.5, so on and so forth. Okay, and it just kind of, you can just give it some arbitrary series. And as long as it has the same length, Python or Pandas can do a group by there. Shoot, okay, I'm going way over time here. All right, so anyway, there's stuff you can do. You don't. Oh wait, no, this is it. This is the. No, this is the. Okay, you don't have to use mean. You can do other things like what's the size, what's the min, what's the max, and stuff like that. Okay, when you do a group by. Okay, when you're doing a group by, it's actually producing a series of arguments, right? So this actually produces a tuple going by the name and the group. And so here, the name is A, the group itself is a data frame, and then you can have it print out the values that it gets, right? So anyway, when you call a group by, it's actually creating kind of an iterable of tuples consisting of the name and the group. Okay, we'll end there. And that's it for today. Did I give you quiz questions? I forgot. The answers are A and E for today. A and E, these are your quiz answers for today's lecture. We have, it's Memorial Day weekend this weekend, so enjoy your extra day off. Take some time to remember those who made the ultimate sacrifice. And we will see you guys on Wednesday. Take a look, check your inbox for an invite from HackerRank to try out the practice test, and we'll see how that goes. That'll be due 1 week from today. So we'll see you guys next Wednesday.